Good morning, my dear friends. My name is Ranveer Kashyap, and today I'm going to make. Today, this video is on physical and chemical changes. Okay, what are physical changes? Changes in the physical properties like shape, size, color, and state of a substance are called physical changes. In such cases, the changes are reversible and no new substance is formed. The basic composition of the substance remains the same. Okay. What is the characteristic of physical change? The first characteristic is no new substance is formed. The second is a physical change is generally reversible and the things can get back to their original form after the change. Okay. The properties of the substance remain the same even if the physical state changes. Okay. If properties like appearance, texture, color, smell, etc. may change in a physical change. Chemical properties of the substance do not change. There may or may not be evolution of heat. Okay. Physical change can lead to change in physical state of the substance. Water can be changed from liquid to gaseous state or solid state, but there is no change in the chemical structure of ice, water, and steam. Okay. Sometimes the substance disappears during physical change but can be recovered after the change. Reversible and irreversible physical changes. A reversible change can be easily reversed by removing the cause of the change, while an irreversible change cannot be reverted back. Reversible changes: melting of ice, dissolution of sugar/salt in water, drying of clothes, sublimation. Camphor. Now, what is sublimation? Sublimation is when a solid directly changes its form from solid to gaseous. Okay, it does not go into the liquid form. What is the irreversible change according to this book? Tearing of paper. Now, the tearing of paper is not an irreversible change, as we can use particular steps to revert the state of the paper into its original form. Okay. Breaking of a glass tumbler, we can just melt the glass. Growth of plants. Now that is an irreversible change, and weathering of rocks is also an irreversible change. Examples of physical changes. Change in states. On heating, solids change to liquids and liquids change to gases. While on cooling, gases change to liquids and liquids change to solids. Some solids directly change into vapors on heating. This process is called sublimation. And when vapors directly change into solids on cooling, this is called deposition. Okay. Expansion and contraction. Solids, liquid, and gases expand on heating and contract on cooling. The extent of expansion differs in solids, liquid, and gases. Gases expand the most, while solids expand the least. Examples of expansion and contraction. In solids, gaps are left in railway track to allow for expansion in summers and contraction in winters. Similarly, electric wires are never hung tautly between the poles to allow for expansion and contraction. In liquids, mercury in mercury thermometer expand on heating and contracts on cooling. In gases, inflated balloons expand or sometimes burst when kept in sun due to expansion of gases, and contract if kept in cold surroundings. Water shows anomalous behavior below 4 degrees Celsius. It expands on cooling and contracts on heating. Okay. Water actually expands when it cools and contracts when it heats. Okay. Dissolution of substances in water is a physical change. Example: solids like glucose, salt, and sugar, etc. When dissolved in water can be recovered by evaporation. Liquid and dissolved in liquid can be recovered by fractional distillation or simple distillation, and gases dissolved in liquids can be recovered by heating. Crystallization. The process of formation of pure crystals of a substance from its solution is called crystallization. Crystals are the purest form solid substance which have a defined geometrical shape. Crystal of copper sulfate from its saturated solution. Now, how do we actually get a crystal? Now, crystal is a the formation of pure crystals of substance from its solution is called crystallization. Now, how can we form crystals? We can, for example, if we dissolve water, if we dissolve salt in water and then leave a rope string which is tied to a stick. For example, this is a glass of water. Okay, this is actually a glass of water. I got it. This is a glass of water. The water in this is is saturated with salt. Now this my hand is a stick and I keep it like this, and but here my a string is tied here, and we just keep the string inside the glass. Okay, now what will happen? After, if you leave this after doing this, after some time crystals of salt will start forming there, halite will form there, rock salt will form there. It may or may not be rock salt, but we can consider it as rock salt as it is in the physical state. Okay, as it is in a rocky form, it is in a crystallized form. Now salt is basically crystals. It is just tiny crystals. The crystal we will get will be a large one. Okay, now if we do it using sugar, it will become mishri, or according to me, I say it crystals because they are crystals. Okay, now what is a chemical change? Chemical changes which involve the formation of new substances, which involve the formation of new substances are called chemical changes. They are irreversible. We cannot reverse them. Okay. Characteristics of chemical changes. Chemical changes are usually irreversible. The original substance cannot be recovered in most of the cases. Okay. Okay, the next point. One or more new substances are formed during the change. New substances have properties different from the original substance. Heat or light both may give off or absorbed during the change. Heat or light or both may be given off or absorbed during the change. Okay. During a chemical reaction, heat, light, sound may be produced. A gas can be formed. A change in color or smell may also take place. A chemical change is also called a chemical reaction. Chemical reaction. A chemical reaction is a process in which initial substances called reactants undergo a change to form new substances called products. Okay. I'm getting tired. Let me just drink some water at first. Now, not Olympiad bite. A chemical equation is the representation of a chemical reaction through symbols and chemical formulae. A symbol represents one atom of an element, while a chemical formula represents one molecule of an element or a compound. A chemical equation is balanced to fulfill the law of conservation of mass, not mouse. which states that matter can neither be created nor destroyed. That is, total mass before and after a change should remain the same. Okay. Characteristics of a chemical reaction. When a chemical reaction takes place, it is accompanied by one or more of the following characteristics. Evolution of gas. A gas may be evolved during a chemical reaction if one of the reactants is a liquid or in solution form. Evolution of gas is confirmed by the appearance of effervescence, bubbling, and is also shown by an arrow pointing upward. Okay. Zinc plus sulfuric acid becomes zinc sulfate and hydrogen. Now, how do we write hydrogen in a chemical formula like this? We write it H2 and then an arrow pointing upwards. Okay. Calcium carbonate, hydrochloric acid, becomes calcium chloride plus water plus calcium plus carbon dioxide. Not calcium, carbon dioxide. Okay. Change of colors. In a chemical reaction, one of the products formed may have a different color than of the reactants. Green copper carbonate. Now copper carbonate is in green color and copper oxide is in black color. And it happens when we heat it. Okay. Now zinc plus copper sulfate becomes zinc sulfate. While zinc sulfate is white in color, the copper sulfate is blue in color.